family. Today too, I am here to take you through the aspect of mathematics which is called trigonometry identities. Trigonometry identities. So I am here to expose you to the basics of trigonometry ratios. The basics of trigonometry ratios. Most students find it difficult, they find it challenging when they are solving for problems which involves this section. They really don't get the accurate understanding. So I am here to give you a brief understanding of the basis of trigonometry ratio. Right now, the basis of trigonometry ratio includes the sine of the reference angle, the cos of the reference angle, and the tan of the reference angle. So here I am going to explain what is meant by sine, what it means by sine, what it means by the cosine, and what it means by the tangent. Alright, so here we are talking about sine of the reference angle, cos of the reference angle, and then the tan of the reference angle. Are you with me? Good. Now let's focus on this question. Let's dive into this question and know how to go about it in an easy way. It says that find the sine theta, find the sine theta, cos theta, and tan theta from the right angled triangle below. So we have a right angle triangle here. Then we've been asked to find the sine of the reference angle, the cos of the reference angle, and then tan of the reference angle. Remember, this is what we call the reference angle, or some people term it as angle of what? Reference. So reference angle. So whether reference angle or angle of reference is still the same thing. All right, good. So let's proceed with life. Now, what I want you to know is this is a right angle triangle, as we have here. It is a right angle triangle. And why is it a right angle triangle? It has three sides. It has three sides, and it has three vertices. Are you with me? So these are the vertices: vertex 1, vertex 2, vertex 3, and then we have side 1, side 2, side 3. Because of this angle 90 degrees here, that is why it is called a right angle triangle. So anytime that you see a symbol like this symbol, it indicates that it is 90 degrees, and therefore this shape becomes a right angle triangle. Now this is where our angle of reference is. Our angle of reference is. Alright, so here sine theta. Okay, alright, now let's quickly dive into that, how to find the value of sine with respect to the reference angle theta. Right, so here we have to know the simplest way of interpreting each of the trig ratio. So interpreting each of the trig ratio, remember we want to, first of all, so let's start with solution. So I am starting with sine of the reference angle theta. So I want to find this value with respect to the right angle triangle that I have here. Right, now sine theta. Okay, remember sine here simply means what? So sine over here means so. Are with me? And so here means what? Opposite over hypotenuse. Remember the O here is the opposite or the opposite. Okay, and then the H here is the hypotenuse. The hypotenuse. Okay, now let's come back to the right angle triangle. We say that a right angle triangle has three sides, and each of the sides has a name with respect to the reference angle. Always the longer side becomes the hypotenuse, where I will say H, which is the hypotenuse, and then always where the angle of reference, this angle where it is facing, where it is looking at, so where the angle is facing becomes the opposite. The opposite let me use letter O for that. And then where the angle of reference is sitting, where it is sitting, you see here it is facing the 2, this side, CA. So here becomes the opposite. And where it is sitting, like getting where it is lying, becomes the adjacent. So adjacent here, where it is lying. So always have it in mind that the longest side is the hypotenuse, and then the side where the angle of reference is facing becomes the opposite, and where the angle of reference is sitting becomes what? The adjacent. Now the hypotenuse is always constant, is that it doesn't change, but with respect to the adjacent and then the opposite, it does what? Changes. I get it. Depending on where the angle of reference is. If the angle of reference is here, it means that this place will no longer be the opposite, rather the opposite comes here, because when we have the angle of reference here, I get it, the angle of reference will face this direction, so therefore here becomes the opposite. But this time around, because the angle of reference is facing this direction, it is facing here. That's why here is called what? The opposite. Please, are you with me? Good. So let's continue with life. Now I said sine of the reference angle means what? So, which is so XOH, SOH. So means opposite over hypotenuse. Are you with me? Good. So let's proceed with life. Now what we are going to do right now is we just look at the triangle over there. We identify the value for the opposite, then the hypotenuse, then we substitute. Good. So let's continue with life. So opposite over hypotenuse. Now opposite, the value for the opposite is here. Looking at where the angle of reference is, it is facing here. So the opposite becomes what? 2. So I have 2 over, remember this is in terms of dimension, so here is centimeters, here 2 is centimeters, and here 2 is centimeters. So I have 2 centimeters over the hypotenuse, which is the longer side. The hypotenuse is h. Let me spell it well. Hypotenuse. Hypotenuse. Alright. So h, which is the hypotenuse, is 5 centimeters. So my centimeters cancels, where I am going to get the sine of the reference angle theta becoming 2 over 5. Are you with me? Very good. So this is what I am getting for the sine of the reference. The value for sine of the reference angle theta is 2 over 5, and that becomes my verb. Great. I believe you understand it well. Now let's continue with the next portion, where I will dive into cos, or cos of the reference angle, which is the cosine. So now that you understand this, let's continue with the next one. So cos of the reference angle theta, that one we say cos means what? Ka. So cos is ka. So remember we have so ka tua. This one is for the sine, this one is for the cos, and this one is for what? The tan. So cos theta means ka, which is ka means adjacent over hypotenuse. Are you with me? Adjacent over hypotenuse. And this is what we are getting. Now what we are going to do right now is we substitute the value for the adjacent. Remember I told you adjacent is where the angle of reference is sitting, where it is lying. Always the angle of reference is lying or sitting. Remember here it is sitting. Assuming we turn the triangle like this, you will see that this one will be sitting, or it will be lying on the adjacent. So the adjacent here is 3 centimeters over the hypotenuse, which is the longer side, over 5 centimeters. The centimeters cancels out, and we are going to get cos of the reference angle theta. The value for this becomes what? 3 out of 5. I believe you are clear with that. So we are done finding the value of the cos of the reference angle. Remember tan theta. Let's do it quick, then after we proceed with line. So tan of the reference angle theta, we said tan means what? Tua. Yes. So tua is opposite over adjacent. Are you with me? And then we have the value for the opposite, where the angle of reference is facing, where it is facing. Always assume that this is an eye. The angle of reference becomes an eye. Where it is watching becomes the opposite. So I have 2 centimeters over the adjacent. The adjacent is where it is sitting. So I have 3 centimeters. So therefore I'm getting my tan or the reference and the theta to be 2/3. Why? Because here the centimeters will cancel, leaving behind 2 out of 3. I believe you are really getting this concept, and it is not anything difficult. Have it in mind that the more you come closer to learn, the more you subscribe, the more you get more information from my end. Have a wonderful day. This is your math teacher, Richard Oben. Whichever problem that you have, bring it on board for further discussion. Have a wonderful day. Bye bye.